Good evening. My paper title is Weighted Sum Method-Based Multi-Objective Optimal Power Flow Considering Various Objectives and Application of Whale Automation Algorithm. Myself, T. Papi Naidu, Associate Professor, Lindy Institute of Engineering and Technology. My abstract is nowadays multi-objective optimization plays a vital role in solving optimal power flow problems. In this paper, weighted sum type multi-objective technique has been used to formulate the objective function. The Whale optimization algorithm has been used to reduce the cost, emission, losses, and voltage stability by considering various multi-objectives like fuel cost along with emission, fuel cost with losses, fuel cost with voltage stability, fuel cost with voltage deviation, and finally fuel cost with emission, losses, voltage deviation. In this paper, the IEEE 30 bus structure has been used to analyze the effect of Whale optimization algorithm on the improvement of system performance. Obtained results with Whale automation algorithm have been compared with other optimization techniques like ensemble, ensemble constraint handling technique with differential evaluation algorithm, the superiority of feasible differential evaluation algorithm. Third one is moth swam algorithm and moth flame optimization algorithm available in literature. In five major objective functions like fuel cost, emission, true power loss, and voltage stability and voltage deviation, the network are taken attention in planning of power system that is employed in Whale automation algorithm. This method is very strong, effective with superior speed to attain the outputs compared to earlier techniques. Also, with increasing the network size and constraints, its effectiveness also increases as compared with the earlier method. The Whale automation algorithm technique is estimated on the Standard Institute of Electrical and Electronics Engineering 30 bus system. The network is studied under different combinations of five objectives, and the best compromise solution is detailed here. The multi-objective OPF issue suggested Whale technique is best while comparing to earlier techniques. This paper is categorized as five sections. Section 2 involves in a multi-objective issues formulation. Section 3 demonstrates about architecture of Whale automation technique. Section 4 is allocated for the results and performance analysis mentioned methods, which we are compared to encounter the literature studies of multi-objective power flow problem on IEEE 30 bus system. And finally, in section 5, the conclusion of the implementation for the proposed technique is presented. So these are my main objective functions. So the multi-objective optimal power flow is nonlinear optimization issue. So these are my different objectives like objective 1, cost minimization, objective 2, minimization of emission, objective 3, minimization of actual power losses, objective 4, voltage stability, 5, minimization of voltage deviation, and multi objectives, reduction of fuel cost and fuel cost with losses, fuel cost and improvement of voltage stability, fuel cost along and voltage deviation, and minimization of fuel cost, emission, voltage deviation, and losses. So, and my algorithm is Whale automation algorithm. So, this Whale automation algorithm is a novel, nature-inspired meta-harvestic automation algorithm proposed by Ali Mirjali and Andrew Lewis 2016, which my social behavior of humpback whale. Whales are fancy creatures. They are considered the biggest mammal in the world. An adult whale can grow up to 30 meters long and ton weight. There are 7 different main species of the giant mammal, such as killer, monkey, sea, humpback, right, fineback, and blue. Whales are mostly considered predators. They are never sleep because they have to breathe from the surface of ocean. Half of the brain only sleeps. The interesting thing about the whales is that They are considered highly intelligent animals with emotion. This is the bubble net feeding of the humpback whale. So next is results and discussions. This paper introduces an optimization approach aimed to minimize the total cost of power generation while considering losses and losses, emission, and voltage stability and voltage deviation. So, and this table indicates the main characteristic of the studied system. That is IEEE 30 bus system. Characteristics is buses 30 buses, branches 41 branches, generators 6 generators like 1, 2, 5, 8, 11, and 13. Load voltage limitations 0.94 per unit to 1.06 per unit. Shunt VAR compensation 9 buses, that is bus number 10, 12, 15, 17, 20, 21, 23, 24, and 29. So transformers with off nominal tap ratio for branches like 11, 12, 15, and 36. Control variables are 24 control variables. Next one is so next one, table 4 indicates this results for a well automation algorithm results with these are control variables, and here the combined fuel cost and emission, and second one is combined fuel cost with power losses. First one, when we are going to take the individual objective, so here the main objective is among all those five objectives. Here the main objective is fuel cost. I need to focus on the fuel cost as a need to reduce. Here the fuel cost is reduced like 800.3196. So here the main objective is fuel cost. Here second case, emission is the main objective. In the emission case, fuel cost is 944.921. But whereas in fuel cost as the main object case 1, fuel cost is 800.3196. And here the second case, emission is the main objective. Here I can reduce the emission like 0.2048 is can reduce. So third case, by combine, case 1 is combining these two. Here the my main objective, I needed to reduce the total fuel cost and the emission. So combine. So when the main function is multi-objective function. Here the multi-objective, in this case the fuel. So case 1 indicates the fuel cost as well as the emission fuel cost as well. Here the fuel cost is 802.172, and emission is 0.3293. Likewise, it is reduced. Similarly, next combined fuel cost along with power losses. Here fuel cost is the main objective, so that 800.3196. And power loss is the main object. Second case, power loss is the main object. Here the power loss is 2.899 power loss. By combining this so multi-object case, fuel cost is 857.81, and power loss is 4.4755 is the power losses. Next one is table 4 indicates the fuel cost along with emission. Sorry. And fuel cost along with voltage deviation. Here the fuel cost is 800.3196 is common, and voltage deviation, here voltage deviation is, so voltage deviation 3437 is the voltage deviation. Likewise, it is reduced. Similarly, combinedly, so power loss is, fuel cost is 800.36 fuel cost. So, and also voltage stability is 0.1266. So similarly, the same case, combined fuel cost along with voltage deviation, when we are going to consider that combinedly, means multi-objective function. Here the individual fuel cost is 800.3196. Similarly, individual voltage deviation is, so voltage deviation 0.2011 is the voltage deviation. So combining these two, 800 power, so fuel cost is 806.105, and voltage deviation is 0.2022 is the voltage deviation. So likewise, we can reduce the total voltage deviation as well as the stability. So next one is, so by in IEEE 30 bus system, so where we're going to consider the multi-object when we're going to use well automation algorithm. So individual, when we are going to consider the individual fuel cost as the main objective, second one is voltage deviation as the main objective, third one is power loss is the main objective. Similarly, emission is the main objective. Here, first one in here In first case, fuel cost is the main object. In this 800.3196 is fuel cost. My focus is only fuel cost. Second case, voltage division is my main focus. Likewise, this is reduced. Similarly, voltage stability 2.899. Third case, emission 0.2048. And by combining Whale optimization algorithm, and we are going to combined means multi-objective fuel cost is 824.82, and emission is 0.2584, and power loss is 5.5871, and voltage deviation is 0.4943, and voltage stability is 0.1468. Likewise, I can reduce all the here. Same table 7, comparison different algorithms with Whale optimization algorithm. Here, these are object like fuel cost, emission, power losses, L index, and fitness function, final fitness function. So here, the main objective is fuel cost. So when we are going to use the Whale optimization algorithm, 824.82 is the fuel cost. Here, by comparing Whale optimization fuel cost along with the ECHT differential evaluation algorithm, SF differential algorithm, and mouth spam algorithm, and mouth flame optimization algorithm. So by comparing all these 4 algorithms, Whale optimization is a effective one. So, and likewise, similarly, emission a ton per hour 0.2584. By comparing, this one is the very less value. Similarly, power loss, Whale optimization power loss is less as compared to the different algorithms. Similarly, L index is very less as compared to the different algorithms. Similarly, case 3, fuel cost, emission, power losses, L index, as well as the fitness function. So by using Whale optimization, by comparing very less values. Similarly, case 2, fuel cost, objective, and L index and fitness. So comparing Whale with other algorithms, this one is very less. This next one is fitness. This is a convergence curve for various cases. So these are, on y-axis I have taken the objective function values, and x-axis I have taken the number of iterations, like 1 to 500 iterations I have taken. So at one instant, so figure 2, this figure shows the convergence curve for case 1 to case 5. From the figure 2, it has been observed that case 5 consisting of multi-objectives produce the compromising solution. Table 6 presents the control variables of all single objectives and multi-objective consisting of all the objectives. From this, it is observed that by combining all the objectives, best optimal values have been achieved. Table 7 presents the comparison of case 2, 3, and 5 of Whale optimization algorithm with other algorithms available in literature. From this table, it is observed that fitness function value with the Whale optimization algorithm is best compared with ECHT, SCDE, mouth spam algorithm, and mouth flame algorithm. So finally, conclusion, the Whale optimization algorithm combined with the optimal power flow demonstrates superior performance multi-objectives, including fuel cost, emissions, losses, voltage stability, and voltage deviations. From the results, it has been observed that by using weighted sum type multi-objective all the objectives optimization simultaneously and provided the compromising solution in case 2, minimizing the fuel cost along with emission, the objective function value is 1036.53 per unit. In case 3, minimize the fuel cost along with the losses, the objective function value is 813.03 per unit. To get the compromising solution by combining all the cases, the objective function value becomes 962.96 per unit. It indicates that all the objectives were optimized simultaneously. The results indicates that when compared to different algorithms with Whale optimization or based approach with regulated variables consistently delivers superior outcomes. These findings have been validated using the IEEE 30 system. So, and these are my, I have taken some reference like 1, 2, 3 up to, I have taken the to taken 15. Some example, I have taken the 15 reference papers from all these. Thank you.